So primarily, the first and foremost is electrical safety. PPE, personal protective equipment, okay, and devices, cover that. Insulations. Insulation's important when you talk about electricity power. It's helpful, isn't it? Right? Okay, necessary. Believe it or not, insulation requires maintenance. We'll cover that as well. Switchgear, breakers, relays, typical components in managing, distributing power, energy, okay, through your facility. All those components are going to require maintenance of some type. Periodic maintenance on a regular basis. Okay. Motor control centers, or otherwise known as MCC, transformer. Cables and trays, conduit. How come we just can't string wire? Just put wire, just nail it to the wall. What do you think? Oh my gosh, imagine that. That's also a code requirement, right? It's got to be protected. So energy, I mean, what, can you actually see energy? I mean, other than if you arc or spark? You can feel it before you touch. Yes, absolutely, right? So it's an invisible energy form, right? Okay. Talk about grounding, and then we'll conclude the evening with some energy management slides. Okay. So electricity is very versatile medium, right? Providing energy, performing a vast array of operations, control functions safely. That's the key word, safely. Extremely hazardous, if not. Therefore, it must be properly respected, applied, and maintained. Okay? So the power infrastructures that we were looking when we had to the two tours, the older central plant and the newer central plant, even though there were two different generations of components, they still require similar maintenance. And probably more so for the combined heat facility, because that's what they're producing is energy, okay, for the rest of the campus. Okay. So basic concepts, I mean, I can't break it down any simpler than this. It starts from the earth, wind, okay. What do you got? Solar, coal, oil, nuclear. Starts from the earth. You have to harvest it. So you produce energy, right? You need a mover to create a pressure differential. So some sort of turbine, steam generator, something that's going to turn and function and act as a generator for power, for electricity, okay, from the very beginning. From that, you need a conductor to carry the medium, power. So you got transmission lines, right, wiring from within a building. Construction projects cover some basic electrical, power construction classes, okay. So power comes in at one end of the building, it goes through all the building, and it comes back out the other end, right, power factor. So believe it or not, the power does go back out, okay? So one of those items is you need an insulator to prevent this escape. It's not like water. You get a pinhole leak in a water line, oh, it's no big deal. Might put a piece of tape over it. It's not that way in power. It's a little bit different media. Then, of course, at the end, it returns back to the earth, otherwise known as the ground. So it has a full cycle, okay? So that's why in power, when you talk about power quality and the power factor is extremely important on how efficient you're operating your facility. Power coming in, power going back out. Some terminology such as dirty power, a lot of computers and components and so on that affect that power factor. Of course, the higher power factor, the better you are. If you have a low power factor, though, that means the utility company has to really generate additional electricity to run it through your facility. That's why SRP APS looks at the power factor and power quality of your facility. To generate more power requires more dollars to do that for generation needs. Okay. So electrical grid, okay. Typically, you're going to have some sort of generation facility, power plant. This one here could be the combined heat facility here in ASU. And then there's that medium. So we're going to conduct and transport it to some sort of substation, switch yard. Okay. And it's diverse. They can go miles. Okay. I was driving to Texas. I was on Interstate 10, and I saw them erecting additional power structures for additional utility. And this was, I was heading up to San Antonio and noticed that. Okay. So from the substation, what are you doing? You're just breaking down the power. So you're going from 100,000 volts, breaking it down to 12 to 13,000 volts. Then if you look, it continues, the medium continues in insulated lines down to a local service entry going into your building. Okay, so why can't I run 100,000 volts into my building? No, yeah, imagine plugging in a toaster. Yeah, you'd have bread done all right, right? So just like we had water pressure regulators, we have dampers and air distribution system, so you're going to have the same transformers, both the buck boost and also standard transformers, and power to regulate and generate the amount of power that you need, okay, for your particular facility. So if you consider from this point to the point where you're maintaining it as a facility manager at your facility, every one of these components requires maintenance, from the point of generation through its transportation and up into your building. Okay, so is that extremely important to have SRP maintain their side of the deal? Sure, right? So I don't have uninterrupted power. Okay, power outages. Okay, typical electrical systems. See any code violations in this picture here? What do you see? Okay, the little transformer here. Yeah. Okay. Yep. Do you notice what's not here? Yeah, a couple of them, right? They really should have doors on them, right? Okay.
I'm sure there's a code violation with extinguishing that's to it also.
Yeah, it's a real tight, confined spot. I mean, it's neat. Housekeeping's good, right?
Where is that?
This is just a random picture that I picked up. But if you consider this is power, maybe a utility, a power, volt. I was looking at this open. This is probably higher voltage breakers. But I'm kind of looking, that can't be the schedule, right? The panel schedule. If it is, it's pretty small. They folded it up real small, right? So again, panel schedule should be very visible. And they probably had these openings for this, these doors. This one here, they might be performing maintenance, but I don't see any mats in front of it. And I definitely don't see any lockout, tagout, okay, documentation. But again, that's typical. So panels, transformers, larger voltage, conduit, mediums, okay. So terminology, just basic terminology, phase, current, okay. Three-phase, single-phase, okay, different types of power applications, okay, for motors and systems. Line current, okay. Neutral, everybody's considered neutral. Preferably no power on your neutral, even though you do have some residual power on that. Okay, grounding, okay. And fuses and circuit breakers, again, what? Instead of having to turn off my substation, I can turn it off close to the source, right? Supports maintainability and allows me access to my equipment, okay? So there's some basic terminology. Now, electrical system components. If you consider every one of these components, if you're going to have a computerized maintenance management system in your facilities organizations or building, these are basically going to be the main groups or categories. So everything from switches, transformers, wiring, believe it or not, bus ducts. In some cases, you'll have bus ducts running above the ceiling where you can connect lab equipment or components down at the floor level. So you'll have twist locks, okay, above the ceiling. Again, ease, flexibility, and being able to apply power to your equipment and systems. Switchboards, distribution panel boards, larger systems, and UPSs. What are those typically for? Uninterrupted power sources. What do you apply those for? Yeah, computers, data centers, right? Anywhere where you have a sag or a spike is going to affect the quality in that particular piece of equipment, okay? Emergency generators, just that, or auxiliary generators in some cases, right? Additional auxiliary power for your facility. Hospital's going to have them. Any other type of industrial? Well, you have them here at ASU. We saw them, right? Okay. You know what? I don't remember. Did you notice anything at the combined heat facility? Were there emergency generators there?
Yeah.
Was there?
Yeah, diesel ones.
Okay. Gosh, I didn't even notice them if they were. Okay. Hospitals would have them, right? Anything to have a critical power factor. Data centers, of course, would absolutely have them. Yep. Pumping systems, pumping stations, and so on. Okay. Automatic transfer switches are associated to the generator. We won't get into a lot of the details in this particular class, but these are just some components that are going to require periodic maintenance when it comes to electrical distribution systems. Okay. GFIs, okay. Power panels, lighting panels, circuit boards, motor control centers, contactors, fixtures, you name it. Even the light fixtures are going to require, the ballast is going to require periodic maintenance. Light bulbs, replacing light bulbs. Light switches. If you consider how many times light switches are used and turned off and on, every one of these components from within a building is going to require a maintenance plan. So with that, you're going to have some sort of job task plan, determining what's the frequency and what's the level. So you're going to have your task, okay, by steps. for every one of these items. Any one of these items fail, it's going to affect your facility. Okay. Typical problems within electrical systems, loose connections. That's where your infrared monitoring comes in. Loose lugs, loose connections, okay. Overheated breakers, transformers, okay, those are going to be helpful. Okay. Overloaded circuits and their motors causing blown fuses or trip breakers. So coordination studies or arc flash studies conducted on your panel systems, on your breakers, going to be extremely important as far as a maintenance program. So what does that got to do with construction now? I mean, you install these as part of instruction, right? So as the shell's going up, you're starting to run your large conduit. You're starting to hang your panel boxes right for the print. But after you're done, right after it's installed and energized, so what then?
Should be inspected.
Right? Yes. So inspection is going to be critical, okay? Commission and making sure that they are, right, one, they're tripping when they should trip, okay? All the maintenance data, okay, that's associated to every one of those breakers and transformers and wiring systems and bus ducts and so on. Those are going to be extremely important. So as project managers, when you turn those over to the facility manager, their job starts at that point. Now I start, maintaining the electrical distribution system. Without power, can I make my mechanical systems work? It's not like I got wind, right? I go out and put my large wind turbines up on top of the roof, rotates my squirrel cages and my air handlers. It's not going to work that way, okay? Other items, believe it or not, dirt, dust. Remember the large transformers, or the switchgear we were looking, remember you looked at the little glass in the older central plant? Okay. Believe it or not, dirt and dust gets into those blades. And then with that, with the humidity, the heat load on them, transferring heat, because as they heat up, they take more current, more load, and then they down at night, okay, they idle down. So all those going to create what we consider where the blades get stuck.
On the high voltage side, do you have to turn that off and actually unbolt the buses and clean them and put them back together?
In some cases, absolutely. You will disengage the blades, because usually on a three-phase you got your three blades. But in some cases, one of the three blades won't disengage. Okay, maybe it's a neutral, maybe it's a phase line two. Okay, those won't disengage, so that requires now some additional maintenance. Because again, first thing you do is you throw a ground to make sure that everything's de-energized, so any prevention of electrocutions. But you go through the lugs, you check, make sure they're tightened. In some cases, if there's corrosion, or electrolysis, yes, okay. You'll go back and you double check those. In some cases, if they're in poor condition, you'll end up replacing them. But conduit, when you talk about 4/0 or 5/0 wire, I mean, is it easy to bend? Have you ever seen that heavy gauge, right? I mean, you gotta be pretty strong to even bend that. I mean, the little 12 or 10 wire, that's a little bit different story. You can bend them with a pair of pliers. But if you're talking medium to high voltage conduit, it's a whole different story. So if you got a corrosion spot, what do? Just go ahead and just pull it up a little bit more? I mean, that's what, encased in conduit that probably runs hundreds and hundreds of yards. That's going to be a little bit more difficult. That's why maintenance, you don't want to get to that point, because then you're replacing it, which becomes extremely expensive. Okay? Poor ventilation in other cases, the cabinet and switchgear must be ventilated, primarily for heat. Transfer heat, that's when you see the vents. So any obstructions, or some cases you're going to have fan-operated transformers, but the fans aren't operating. There's a chance of the system's overheating, which creates failures, right? Lack of PMs. Yeah, in some cases it's just energy. It's like the wall outlet. Hotel rooms, how many times have you gone into a hotel room, you plugged a hairdryer into the outlet and it's loose? Ever run into that? I mean, the whole outlet is loose. So then you kind of jiggle and it's like, gosh, I wonder how many more times this is going to last like this, right? Okay. Or like me, one time I plugged the iron into the outlet and I blew out the entire floor. They traced it to my room, by the way. So, but but I did call the front desk. It says power went out when I plugged in the iron. So the service technician went up there. But when he took the wiring out, it was pretty bad. Okay. I probably won't stay there again. Improper insulation. Water and moisture. Water and electricity mix? No, right? Okay, definitely want to keep those two separated. Routine maintenance is infrared scanning, cleaning, lubrication. Exercise is one item that's not up there, is exercising your switchgear on a regular basis, once a year, twice a year. In some cases, you'll rack them out and rack them back in. But again, every one of those has a mechanical type feature to it. Every one of them has to be greased, lubed, inspected, and also worked, okay, to prevent that. In the event of an emergency, I don't want to be contending with a gear that's not de-energizing, okay, when it should. Testing and, of course, tightening, what we had talked about before, okay. Electrical safety, lockout, tagout, I think everybody's aware of that. That's number one OSHA requirement. Making sure that your electrical switching is properly disengaged or de-energized. And they're in those protocols. If you ever watch SRP when they conduct service work, either on a line, a high voltage line, or even with their substations, they have an entire itinerary. They'll meet with the entire crew for up to an hour before they do anything. And they go over the protocols and all the procedures and who's going to do what and when. And that's primarily because your life is in another individual's hands. So they want to make absolutely sure everybody knows exactly what they're going to do when it comes to servicing that high voltage. Okay? It only happens to you once, and that's all it takes. Okay? That's when it's extremely important. By the way, can 110 volts kill you? Absolutely, right? Some folks think, remember the old days before they had ohm meters? You should do the finger. Yeah, it had a lot of calluses, right? It's like, yeah, I don't know, let me try it again. That's that's not, no, that's back in the day. Okay, nowadays, no, that's a no-no. Okay, grounding, regular grounding to make sure it's properly grounded and supports the load. Confined space. So what's confined space? So I have an electrical utility vault that's buried 12 feet into the ground. It's got a lid on top. Typically don't have a light in there, so it's dark. No ventilation, right? Confined space, is that hazardous? Right? So with that, you have special permits, and then what? You're going to probably have some sort of harness for emergency extractions in those cases. But all those are going to be considered safety requirements, and probably conduct regular testing. How about PPE? What's some of the gear that you would wear? Harnessed.
Rubber-soled shoes.
Okay, good. Okay. Gloves. Okay. Eye protection, typically a mask. Hoods in some cases, the full gear, right? Okay. You're going to have your hot sticks going to be associated with that, okay? And it's all specialized training. It's not like anybody can just don the gear and says, let me at it. It's all requires specialized training that's right, OSHA approved in regards to that. So again, part of construction, energizing, same drill. Same PPE, same requirements as you energize. You know, probably one of the scariest things is when you throw in that disconnect switch and your service main, is it doesn't trip. Because then that tells you somewhere along there's a short, right? So preferably you turn it, everything starts humming. It's like, ooh, good. Well, we passed that test, right? Okay, after that.
Well, you get a hot test prior to energizing now anyway.
Yeah. So there's precautions that are baked in, okay, right into the commissioning phase. Okay. Different types of insulators when you talk about power systems and distribution systems. Flexible insulators, some cases where you need that pliability, okay, for your connections. Rigid, okay. Some cases you're going to have rigid insulators, primarily in large distribution systems coming into your facility. Solid insulators. Liquids and gases, primarily to deal with transformers, okay. Those applications there. And believe it or not, in some cases, like liquids and gases actually have a maintenance property associated to them. Okay, the level of toxic gases and the level of certain types of gases will tell you the indication of what's happening inside that transformer. Same thing with oils. Mineral is typically inside a transformer. You go out every couple of years and you actually draw a small amount of oil. And you have that analyzed. Just like you do for your greases and other types of lubricants, you're going to do the same thing for your transformers. What you're trying to do is predictive maintenance. Determine is that transformer functioning, or is there cases of overheating? Maybe there's arcing going on from within the transformer. Because remember, our motto for maintenance, minimize unplanned downtime. Okay, and those are some of the properties in regards to insulators. So believe it or not, even though, gosh, it's just an insulator, do I really got to perform maintenance on that? Absolutely. Okay. Some of the properties for insulation maintenance is resistance measurements. Okay, you run meg tests on those. Okay, for resistance. Okay, is going to be one quality. Okay. Insulation breaks down over time. Okay, absolutely. Wear and tear on it, heat loads. Okay, and in some cases, if it's direct burial, okay, you'll be surprised what attacks conduit. Okay, okay, rodents, and you'll be surprised what you find, what causes that. SRP had a problem with a lot of the bird population, believe it or not, attacking their substations, and in some cases, you find.
Intel had knocked out their system.
Yeah, and that's amazing. During the monsoon storms, when you get the dust storms, right? Patio furniture, ladders, you name it, that comes across those, and it's real, right? Occurs all the time. Some cases you get, cats, pigeons, squirrels, name it. If their span's long enough to catch the two phases, that's enough for a catastrophe. Okay. Internal and external moisture. Some cases you don't really want to bury that underneath your pool, okay, or next to a reservoir. So again, utility siting is going to be as important. So again, landscape architects, I always say they're not a facility manager's friend, but in some cases after you bury it, who knows what's going to happen above it, okay? And of course, the moisture, internal moisture from within your building. High humidity areas, okay? Levels in regards to electrical volts, typically air conditioned. Okay. Internal, external service deterioration. Erosion. Sometimes erosion will expose, right, your conduit that's buried. Some cases, if you have direct burial, big items are called backhoes. Okay, so blue stake is going to be extremely important. That's going to be one of your safety precautions. Believe it or not, it happens now. Luckily, it wasn't a medium voltage line, but we've got some formwork going on at my facility in Scottsdale. And a general contractor took a 3-foot spike and drove it through a 3-inch water line. Okay, I mean, when it started leaking water, you figured he'd stop, but he drove the spike through the entire. I mean, that took some pounding to get to that copper line. But again, those things happen. Okay, power's no difference. Okay, magnetometers. In regards to testing, what is the resistance and the quality of the insulation? Okay, from within your particular. Because you can't see it. I mean, it's not like you can pull it out and visually inspect it and put it back in. Okay, so in some cases, you're going to have to rely on technology for that. Okay, and this type of work, though, is typically going to be outsourced. Okay, to a qualified, what I call specialty contractor. That's what they specialize in, is checking the insulation and the property of the insulation. Okay, so in facilities, one of our maintenance requirements is going to put that on the regular periodic maintenance plan. So if it's twice every 5 years, if it's once a year, depending on what the application is going to be, you're going to call in the specialty contractor, they're going to perform the maintenance. So then I get back to construction, making sure that they got accessibility to the components and the gear. It's not an item to where I've got to go down into the basement through 2 different types of security checks, something that I can easily access maybe right off of the street. So service entries, we'll cover some of that here in a few slides up. Service entries, separate door, you come in off the street and you perform all the maintenance separate from the rest of the facility. So again, you don't disrupt the occupants and employees. Okay, and then temperature sensitive. Okay, and bottom line, it measures the insulation degradation. So when it starts to degrade and you start to keep track, it's almost like your vibration analysis. Okay, when you start to see additional vibration that's above and beyond the original baseline. Now you start to track that. So as the degradation gets down to a certain level, then it's time for replacement or refurbishment.
Do you only track that on larger pieces of equipment?
Typically, anything above 4160, you're going to measure that, okay, in regards to degradation of the insulation. Okay. Okay, this one here, I knew that was going to do that, so we'll go on to that one there. Okay. So dielectric losses and power factors I was mentioning a little bit before. Okay, to whatever you do in power, you're going to have some sort of resistance and some sort of losses. So if I'm getting a full 208, 480, I'm going to have some sort of losses just based on the nature of power as I'm running it through my conductors and medium. Okay, increases in loss again is going to have some sort of potential failures. That means somewhere along the line I've got a breakdown in insulation. And it's not only in wire, it's also inside motors. Because if you consider inside a motor, it's just a series of copper windings. Okay? So even within that motor, called the MEG test, you're going to conduct those analysis, those maintenance, if you will, properties to determine what is the breakdown in this motor. So once I find that in a particular device, motor, if you will, and then I'm going to basically take that motor out of service, either replace it if I have a replacement. That's what they were doing with the old central plant when they had those large motors taken out. Those were discovered during routine MEG tests. If I don't address it at that time, eventually it's going to end up as an unplanned failure. Okay, typically, the damage at that point is beyond repair. So it's not just a simple refurbishment, I get the motor back. In some cases, it may be a full replacement, additional costs. Okay. Gaseous installations do not have measurable losses, okay, unless overstressed and ionized. So that's what I'm looking for when it gets into my transformers. Is what in that gas, okay, sample. There's certain levels that's let me know, as I mentioned before, what's happening inside that transformer. Transformer is taking high voltage power and breaking it down to a usable voltage, okay, current capacity. Okay. Solid insulations typically have some sort of air voids, again, for what temperature, okay, and to maintain some sort of consistency. Okay. If overstressed, again, ionize and fail, people always ask, on the medium transmission lines, there's 65 kVA, in some cases 100 kVA, 500 kVA. Does the metal deform? What do you think? Think the metal deforms?
No.
Believe it or not, on some of the, if you ever drive up to Payson, you come underneath SAPS's 500 kVA lines as you're going up into Payson. Check those out when you drive up there during the wintertime versus the summertime. You could have up to a 3 to 4 foot sag on some of that.
Isn't that due to just heat changes in metal?
Oh, yes. And then with the weight of the metal, too, right. The weight of the cable. Right. Right. So that's when they talk about outages due to a tree. The tree is, gosh, it's 5 foot, so we got plenty of time. But if you have a few full load, those lines do tend to sag. And, of course, once they touch the tree, and then you've got an interruption. And that affects the entire grid. Okay? So absolutely. So, again, ionized and failing. Dielectric losses typically increase in insulations as the temperatures rise. So that's another indicator. Your infrared. Okay? Checking out the insulation temperatures as not only in your visible switchgear, but what's behind the cabinet as well.